Strong acids and bases, presented by Lucas and Logan. So, what are strong acids? Strong acids are classified as having a pKa that is less than 0. Some people may say less than -1. I did research and came up with 0, so that is the number I am using in this. pKa is basically just a number that describes the acidity of any particular molecule. But how do we know what the strong acids actually are? So, there are 7 main strong acids. The 7 main strong acids are hydrochloric acid, HCl, hydrobromic acid, HBr,
hydroiodic acid,
nitric acid, sulfuric acid, perchloric acid, and chloric acid. All of these have the same feature of having pKa's of less than 0, which means they're all classified as strong acids. Hydroiodinic acid is the strongest with a pKa of negative 9.3. Now, the difference between a strong acid and a weak acid is weak acids don't fully dissociate in water. They are mostly dissociated, but not fully. They turn into weak bases when combined with water and are reversible, which means when you draw the equation, you would draw 2 arrows instead of 1. You'll see that later in the presentation with weak bases and strong bases. Strong acids, on the other hand, fully dissociate, neutralize, and are not reversible. It is with strong acids, like HCl, if you make them into a salt, they become neutral. So NaCl is neutral, it's table salt. Weak acids, on the other hand, will turn into weak bases. Add Na to hydrogen fluoride, you will get sodium fluoride, which is a weak base. Now it is time for strong and weak bases.
Strong and weak bases. So, in order to tell apart the strong and the weak bases, a strong base when mixed in water will fully dissociate. As you can see here, there's a single arrow that goes between the strong base and the weak base. That shows us that it will fully dissociate into the water. It won't go back and forth, and so sodium hydroxide will become Na positive and OH negative ions. Then here we have magnesium hydroxide. Now that is a weak base. It does not fully dissolve in water. So you see it goes back and forth. A little bit dissociates, and a little bit of it stays as magnesium hydroxide. That makes it a weak base. It will release less hydroxide ions. That's how we know if it's a strong base or not. A basic solution will have a lot of hydroxide ions and not a lot of hydrogen ions. So the more it dissociates, the stronger of a base it will be, because it will release more hydroxide ions into the solution. Now, for an example, if you were to take a weak acid, like hydrogen cyanide, has a low pH, and turn it into its conjugate salt. So this means you keep like the cyanide part of it, but you get rid of the hydrogen, and you make it a basic salt, like potassium cyanide, which is a weak base. You notice how a weak acid will become a weak base? It's like a really strong acid, like
hydroiodic acid.
We turn that into a salt, like potassium iodine. Now it's a neutral salt. You see how a strong acid, its conjugate salt, is going to be always neutral. That's the fun part about them. It's an easy way to tell. If we're dealing with a weak acid, its conjugate will be a weak base. If you're dealing with a strong base, its conjugate will be a neutral liquid. It works like that. So, in conclusion, we have our 7 weak acids and our weak bases. Our weak bases are anything that has a hydroxide base and is soluble in water. And remember, the conjugate of a strong base will be a neutral liquid, and the conjugate of a strong acid will be a neutral salt. Thanks for watching this video on strong acids and bases and their equations.